3.1. The following paragraph describes how coastal processes are linked. Complete the paragraph, choose the correct words from the list below. So, erosion and weathering breaks down in coastal areas. Sediment is transported by the action of the waves and tides, and once the waves and tides have lost energy, deposition takes place. So you've got 1 correct for 1 mark, 2 or more correct, 2 marks. Question 3.2. Study the figure, which is a diagram showing features of coastal erosion. Complete the diagram using the following terms. So, the first one, this one here, would be a cave. Then you've got the arch. This one here is the stack. And then this one's a little bit tricky because the wave cut platform here will be the piece of the cliff that is submerged underwater, that is joining the headland to the stack here. So wave cut platform would be this one here. Question 3.3. Suggest why the coastal area shown in figure 11 needs to be protected from the effects of physical processes. Okay, so first of all, it just says figure 11, not your own understanding. So it's got to be something we can see in the photograph. So we could have damage to property and lines of communication, which may be very costly to repair. You could have the idea that it's going to be quite expensive to stay in other places, hotels, etc. Or it might be expensive if you're having to travel further to get to work, if you are having to live somewhere else for a period of time. Maybe some of these places in this photograph you can argue are businesses as well. So you could say obviously they're going to lose money if people obviously can't get to it. You could say the closure of roads or in railways means extensive detours. So you're going to have probably a lot of congestion, a lot of traffic jams, which means people might be late for work, so meetings might be cancelled, costing a lot of money. Or finally, you could say homes could be insured, but if for whatever reason the road sort of collapses in, like we've seen in this part of the road, then if they are insured, then perhaps they can get the money back for the things that they've lost. They'll just have to pay a lot more the year after their claim. 3.1. With the help of figure 12, explain how soft engineering is used to protect coastlines from the effect of physical processes. So first of all, soft engineering, this is not things like groins, seawalls, riprap, because that's all hard engineering. So you don't get any marks for saying those. But also, it says figure 12, but also with the help of. So we can use this image, but then bring in our own understanding as well. So in terms of soft engineering, one of the things that we can do to protect the coastline is beach nourishment. And this is where we get the sand that has been dragged back out into the sea, and we can dredge it up, and then we can spray it back onto the beach itself. Now, the positives with this, obviously, if you have a bigger beach, this is basically a natural barrier between the sea and maybe the houses just off the beach. So if the beach is bigger, the waves are going to slow down as they go onto the beach. So hopefully the flooding or the amount of erosion that's going to happen at the back of the beach is going to be less. The next type, sort of very similar, this one's called beach reprofiling. It's basically where you pay someone to come and you just basically push the sand to the back of the beach. And this sort of consolidates it all together, so it's a bit harder to move. But as it's further back again, it should act as almost like a natural barrier between the sea and the houses behind. So the waves, the energy of the waves will be absorbed in these mounds of sand rather than eroding the coastline behind. Well, finally got something called dune regeneration. So inside each of these green plastic tubes, you're going to have some small trees or plants, vegetation. And the idea being that as the wind blows the sand onto the sand dunes, the vegetation will slow the wind down, so it'll encourage the wind to drop more sand to make the sand dunes bigger. And if the sand dunes are bigger, then again, it's that natural barrier between the sea one side and people's homes or the cliffs the other. Also, why planting trees is so useful is because underneath the sand, all of these plants will have their roots and they will spread as the plants get bigger and bigger. And the roots basically hold all the sand together. So it basically ensures that you've got this natural barrier and it is going to be stronger. So as long as you explain a couple of those, a few of them are implied in this picture anyway. This looks like maybe beach nourishment, just getting the sand off the beach and putting it back on. So as long as you explain a few of these and what they do and why they're useful, you should get a good mark. 4.1, study figure 13, a diagram showing features of the lowland river valley, and complete the diagram using the following terms. So first one here, that is an oxbow lake. This one here is actually not pointing to the river itself, but just next to it, this will be the floodplain. This bit here, this curved part of the river, that is the meander. And then finally, the last one is the estuary. So you get 1 mark for 1, 2 marks for 2, or 3 or 4, you get 3 marks. Question 4.2. The following paragraph describes how sediment, so material, is transported by a river. You just got to complete the paragraph using these 3 terms. Sediment is moved downstream by rivers in a number of ways. Small sediments and tiny sediment are carried by, the first one is suspension. If you can imagine very tiny particles, they're floating within the water. So they're suspended actually in the water. While larger pebbles are moved along the riverbed in small hops. This movement is called saltation. So this is bigger pebbles, instead of floating in the water, because they're heavier, they're sort of jumping along the bottom of the river. So that is saltation. And then larger materials, the big boulders, they're sort of pushed along, always in contact with the riverbed, and this is by traction. 4.3. With the help of figure 14, explain how physical and human factors can increase the risk of river flooding. So we've got to use the figure, but it says with the help of, so we can use our own understanding as well. Physical factors, these are things that are not man-made. So what naturally happens that makes an area at risk of flooding? So I guess the most obvious one would be the weather. If it rains a lot, then the chances of flooding is going to be very, very high. But in terms of our example, we've looked at Boscastle flooding. So if you can cast your minds back, think, why did that place flood? Well, yes, there was a lot of rain, but there was also a lot of steep slopes. And here's where a lot of key terms could be quite useful. You could say, as water falls on steep slopes, surface runoff, which is the movement of water on the surface, happens really quickly. So in other words, it rains, but the water travels to rivers very quickly. So the chance of flooding is obviously going to be higher. In terms of human factors, well, we can see in this town here that there's lots of roads, there's lots of houses. So we could say there's lots of impermeable surfaces like concrete and tarmac. Impermeable surfaces just mean surfaces that don't let water go through them. So they'll stay on the surface, and therefore the likelihood of flooding is obviously greater. So like I say, in terms of figure 14, the roads, the tarmacs and the concretes are there. Also, you could have another human factors and say the cutting down of trees, the deforestation. If you cut down trees, then there is less what's called interception, because trees normally collect the water on the branches and on the leaves, so it doesn't go straight away into the rivers and maybe cause a flood. But if trees are cut down, maybe to build, maybe to have room for buildings to be built, that could lead to flooding as well. Or you could actually say the impermeable surface could be just a natural thing, a physical factor. If there is hard rock down, the rock again won't let water through it, and also act as the same as concrete or tarmac. So as long as you explain physical and human and reference figure 14, we should be getting into the higher marks. Question 4.4, study how the flood management scheme in Boscastle, shown in figure 15, helps to reduce the risk of flooding. So we're going to have to reference figure 15 in terms of some of the specifics that have happened, but you could also see you've got a scale, so you can maybe say how big some of these things are, and then compass points to maybe just give an idea of where the management is taking place relative to the river. So in this example, just the north. So a few things we can look at. First thing, this was the original river channel, but they've moved it slightly and made it wider. That's going to work because if the river is wider, or indeed if it is deeper, it's going to hold more water. So if it holds more water, there's less opportunity for the water to overflow. You've also got, as we can see here, over 50 metres of trees that have now been removed. That is good because if you remember in Boscastle, why it flooded so bad is because a lot of debris that's been washed into the river, such as the trees, got stuck underneath the bridges, which basically acted as a dam. So the river just spilled out from that point. So removing those trees removes the obstacles. And let's have a look. You've also got a path here, Riverside Walkway, they've called it, for over 300 meters of it. Why is that going to be useful? Well, if you remember what Boscastle was like before, there were loads of buildings really close to the river Valency. So by moving the buildings sort of further away, raising the car park, having this almost barrier to say we're not going to build that close to the river. So if the river does flood, it's got less opportunity to ruin people's property and instead just go on the path. So as long as you explain those, you make sure you're referencing the figure, you should get full marks for the final question.